So problem number 2 is question 2000 from the 2005 exam. It's question number 4. And the reason I included this one is not just because it was a hypothesis test, but because the way the conditions work on this one, although they have the same conditions, the way you actually write the conditions are slightly different. So I want to point that out when we get to it. So some boxes of a certain brand of breakfast cereal included a voucher for free a video rental inside the box. The company that makes the cereal claims that the voucher can be found in 20% of the boxes. So they've made a claim of 20%, and because it's a hypothesis test, we believe them until we can prove them differently. However, based on their experience eating the cereal at home, a group of students believe that the proportion of boxes is less than 20%. This group of students purchased 65 boxes of cereal to investigate the company's claim. The students found a total of 11 vouchers in the 65 boxes. All right? So right there, they're telling you, hey, you know what? We have 11 out of 65. So this would let me know that I have a p-hat of 11 over 65, whatever that is. Suppose it's reasonable to assume that 65 boxes purchased are a random sample of all boxes of the cereal. Based on the sample, is there support for the student's belief that the proportion of boxes with vouchers is less than 0.2? Provide statistical evidence to support your answer. So the company's claim is 20%, and I'm going to go with a less than 20% because that's what will upset the students. If it's more than 20%, they're going to be real happy that their Happy Meal cereals have more vouchers. All right? You always must define a parameter, and it's the true population proportion of boxes that contain vouchers. That's what we're looking for. So the conditions, as I noticed, there's going to be a slight difference here. Random sample of 65 boxes that was given in the problem. That's no difference than problem 1. N is less than 10%, so 65 divided by 0.1 is 650. Reasonable to assume that they make at least 650 boxes of cereal. But here on part 3, when we're checking to see if the sample is large enough, this is where we have a slight difference. And our slight difference is this. In the previous problem, they gave us p-hat, and here they didn't. So in the previous problem, we had the sample size times p-hat, and we had to calculate. Here they told us, we have 11 boxes that have vouchers, and that's what we consider success. And then our failure, the ones that don't have boxes, the vouchers, are 65 minus 11 is 53. So basically, very, very slight, but that's all you need to do. The previous one, the previous problem, sample size times p-hat. Here they gave us the number of successes and the number of failures. So we just needed to write that down. All right, as I said, p-hat was 11 out of 65. And I'm going to real quickly address just a couple things. One, you notice that I've already recorded that I called it a z-test. If we're doing a test of proportions, whether it's 1 sample or 2 sample, confidence interval or hypothesis test, it's going to be a z. All right? The next thing you need to know is, like, how did I know it was a proportion test and not a mean test? Well, first off, they kind of gave me a ratio, 11 out of 65. That may have been my biggest hint, but there are a couple of other little things. If they give you a list of data, it's probably going to be means. If they say the word mean, it's going to be mean. If they tell you standard deviation, if they give you the standard deviation, and well, for a test of means, they'll have to either give you a list of data and the mean, or the mean and the standard deviation. Here, they just gave me 2 numbers, and it was part to whole. Consequently, I was working with a proportion. Besides that, they said 20%. So those things let me know that I'm working with proportions, and all proportions are z-tests. All right, so I plugged in, I just went ahead and wrote the formula down, which, since you're going to have access to a formula sheet, it's not that big of a deal. P-hat went directly there. My claim of 20% went there. And please note that I used my claim in the denominator. And the reason being is I believe it to be true until I prove it otherwise. This is different than a confidence interval. A confidence interval, this will be p-hat. But for here, for a hypothesis test, we have to use whatever they claimed it to be. So let's go ahead and run this test real quickly. So it's stats test, 1 proportion z-test. Our claim is 0.2. The number of boxes with vouchers is 11 out of a total of 65 boxes. We're going to be upset if it's less than. That was our alternative. And we calculate, and we end up getting a p-value of about 0.276. All right? So the probability that z, and this should have been less than, that's a mistake, z is less than negative 0.62 is 0.2676. All right, our p-value is greater than 0.05. So when I compare my p-value to alpha, it's greater than, so we're going to fail to reject the null. Our p-value is 0.2676. We fail to reject the null. There is not sufficient evidence that alpha equal 0.05 to suggest the true population proportion of cereal boxes containing vouchers is less than 20%. In other words, we do not have enough evidence to say the company is not including vouchers in 20% of the cereal boxes. All right. Now, please note, I didn't say we proved that they had 20%. We didn't. We just say there's not enough evidence to say that they don't have 20%. So we can't conclude that they don't. So we can't say that the company is shorting these college students. They apparently are getting all the cereal vouchers they're supposed to get. All right.